This is our first lecture for the stoichiometry unit, and it says it's the math of chemistry. That's when we're actually looking at a chemical equation and calculating various amounts that are involved for reactants and products. The mole is going to be key to these calculations, and that's why we see the mole here in his comfy chair. In order to do the math, first and foremost, you must have a balanced equation. Every single problem has to start with a balanced chemical equation. We're going to use those coefficients in the equation in order to switch from the moles of one substance to moles of another. So these values in front here in my equation actually represent the mole amounts. So you need to understand this concept of mole ratios, and we're going to try writing a few of them. Essentially, the way I would read this equation is I would say for every 2 mole of C2H6 that react with 7 mole of O2, it will produce 4 mole of CO2 and 6 mole of H2O. So let's look at one of the ratios. Here's an example of a ratio using the two reactants, the C2H6 and the O2, and I've written it as a ratio, 2 mole of C2H6 over 7 mole of O2. Let's try another one. Here I'm comparing one of the reactants with one of the products. For every 7 mole of O2 that are used, 4 mole of CO2 should be produced. So when we ask for a mole ratio, you basically can look at any two substances in the equation and list them one over the other using the coefficient and the unit of mole with the chemical formula. Let's look at one final example comparing the products. Here we see for every 4 mole of CO2, we're going to get 6 mole of H2O, and they're listed here as a ratio. Any problem can be started using a reactant or a product. So sometimes that throws a student. She sees that it starts out with so many grams of a product, and she thinks, well, I already have product, how can I solve this? But basically what we just saw with mole ratios is we can do comparisons between any two substances. Now you want to read the problem carefully and ask yourself a couple of questions, because I don't want you to do more work than you need to. Is it just what we call a mole-to-mole calculation? And how would we identify? If there are no grams given or asked for, then I'm only going to use the balanced equation with those mole ratios. If mass is given or asked for, then I'm still going to use the balanced equation. We have to have a balanced equation every time. But I'm also going to use molar mass. I might only need one, I might need more than one. I'm going to let the way the question is worded guide me in making that determination. Let's jump into some calculating. I like to take notes under the balanced equation, and then I don't have to keep going back and rereading the word equation. I can see that this is asking for how many moles of KClO3. So I'm literally going to put a little question mark and the word mole under KClO3. As I continue reading, I see that it gives 9 mole of oxygen. So that's actually my given, and I'm going to put that under the oxygen and its mole. This shows me where I want to end up, KClO3, and it shows me where I'm starting. We're going to be using the given over find method that we learned in the first semester, so you're already familiar with it. We want to have given over find, and we've identified the given, 9 mole of O2. Now, last semester you only had to put the number and the unit, but what's new with stoichiometry is we also need to list the substance. So we still need to list the number, we still need to list the unit, but the new piece is we need to list the substance, because we're switching from one substance to another. So it needs to be very clear to us what we're working with. I'm going to put that over find. I need X mole of KClO3. Now pause for a minute, looking at this question, and ask yourself, do you need to calculate any molar mass values? Hopefully you're recognizing that you do not. There are no grams given. It does not ask for mass, and it does not ask for grams. So we're going to come over here to the other side of our equals like we did last semester. And I'm curious if you remember, what do we need to put on the right side? Well, we want to do this matching on the top and the top. So I want to put mole of O2 on the top because it needs to match straight across. And I want to put mole of KClO3 on the bottom. Now, the question is, what values do I put in front of that? And this is where that balanced equation comes in handy. For the moles of O2, I'm going to look up here in my balanced equation, and it has a 3 in front. So I'm going to put a 3 in front of moles of O2. I look for KClO3 in the equation. It has a 2 in front, so I'm going to put a 2 in front of moles of KClO3. These values, and you want to make a note, come from the balanced equation. Make sure you have that in your notes so that you can remember where the 3 and the 2 come from. At this point, we just want to cross multiply and divide. So I have 2 times 9 divided by 3, and that gives us an answer. Go ahead and pause this to calculate it on your own, and after you've calculated, start the video again to see if you get the same answer I do. Welcome back. I hope that calculation was kind of quick and easy. I get 6 mole of KClO3. And if you couldn't remember what you were solving for, look back up here where you put that question mark under KClO3 in the equation. So pretty short, quick, and easy. This is the shortest type of stoichiometry problem, doing a mole-to-mole calculation.
Okay, this is Miss Mack taking over for Miss Shelley. We're going to continue this, and so let's see what our problem says. How many grams of water? And like Miss Shelley, I do like to kind of, how many grams of water, so I'm kind of looking for that, are required to produce 1.55 moles of acetylene. So that's the C2H2, so that's this stuff here. So I have 1.55 moles of the C2H2. So I'm going to do my given over my find or my looking for, and I'm given 1.55 moles of C2H2. Notice I write moles and what the substance is. And then I'm looking for grams of H2O. Okay, so it gets a little icky if we keep writing our units here. We do need to put the same substance across from the same substance. So C2H2 across from, so notice that these are the same, C2H2, and these are the same, these are both H2O. All right, if I'm just dealing with the moles, then I use the coefficient. Well, there's like no coefficient here. What's it understood to be? Yeah, just like in algebra, you don't write 1x, do you? You just write x, and so there's an understood 1 there. And then grams, we're going to put the coefficient, but the coefficient in front of water is not 1, it's 2. So it's a 2 here times the mass of water. So we're going to, the coefficient and the mass. And you go pause this, find the molar mass of water, and we'll see if it matches mine. Okay, so I hope you found that it's 18.02 grams per mole. So now we're going to do the math. Pause it, see if your math matches my math. So I get that my grams of water equals 55.9 grams. I actually got 55.86, but I rounded that up to 55.9. Okay, so where did these numbers come from? This is the coefficient from our balanced equation. This is the molar mass. This is the coefficient. Now, why didn't I put the molar mass up at on the top? Remember, I was already given moles, so I was already at moles, so I didn't have to use the molar mass. So you only need the molar mass when somebody says something about grams. Okay, another example. Let's see how we can do this. How many moles of NH3, so we're going to put that under there, will be produced when 4.5 grams of N2 reacts? So given, find, so we're given 4.5 grams of N2, and we're looking for X moles of NH3. All right, so N2, NH3. Notice I'm putting those in first so I don't mess it up. Okay, I'm always going to use the coefficients. So I can go ahead and put my coefficients in. Coefficient in front of the N2 is a 1. And the coefficient in front of the NH3 is a 2. Now I need to figure out which one needs a molar mass. Okay, the only ones that need a molar mass are the gram ones. So the only time we have grams is here. So this guy here needs a molar mass. So the molar mass of N2 is 28.02 because it's 2 nitrogens. Okay, and we don't have to put the molar mass in the bottom because we have moles there. We don't have grams. So again, we're going to cross multiply and divide. So let's see what we get. You do the math, I'll do the math. We'll see if our answers match. All right, I got that X is 0.321 moles of NH3, because remember I was looking for moles of NH3, so that's how I knew my answer was in moles. See, not so hard, huh? All right, 2 more examples. How many grams of oxygen are required to completely react with 14.6 grams of sodium? So notice we're not doing anything with the sodium oxide. We really don't care because nobody asked us how much sodium oxide or nothing. So we don't care about it. So looking, let's do this right, Miss Mac. Given over looking for, we're given over find. All right, so we're given 14.6 grams of Na. Notice I'm putting the unit and the substance, and I'm looking for X grams of O2. All right, so over here I'm going to put Na, and I'm going to put O2. Always going to use the coefficients. So the coefficient in front of Na is 4. Coefficient in front of O2 is 1. Now, do I need the molar mass on the top? Yes, I do, because I have grams. That's the big hint that I need the molar mass, is somebody said grams. So sodium is 22.99. Do I need it on the bottom? Yes, I do, because we have grams of O2. All right, so it's O2, 2. So I need 2 oxygens. So this is going to be 32 grams per mole. Same math, cross, multiply, and divide. See, not hard. Cross, multiply, and divide. We did a few more numbers, but we can do this. All right, let's pause it. Let's see if we can get it. Did you pause it? If you didn't pause it, you better pause it now. Here comes the answer. All right, we get 5.08, and then we were looking for grams of O2. So there's our answer. All right, one more. Oh, no more. Look. Anyone can be cool, but it takes practice to be awesome. You can do this. All right. We'll see you in class.